All right, I want to go over some examples of using the power rule. Now, I mentioned in the last video, the power rule works not only for positive integer powers, but also for other powers like negative powers, fraction powers, irrational powers, all of them. The power can be any real number. So let's look at an example of something like 1 over x. This function 1 over x can be rewritten as x to the power -1. It's going to become very important for you to remember how negative powers and fractional powers are interpreted as ratios and as radical functions in turn. So it was like respectively, that's what I was looking for. So in particular, when you have like 1 divided by a power of x, then that power can be interpreted as a negative power of x. All right, just a little review on algebra. So if we want to take a derivative of this, f prime, let's put f prime over here. All we need to do is apply our power rule. So remember what the power rule says. It says take whatever that power was there. We're going to make that a, we're going to do a couple of things with that. We're going to make it a multiple in front, -1 times, right? And then we're still going to have a power of x, but the power is going to be 1 less. We're going to take this power and we're going to reduce it by 1. Now, -1 minus 1 is -2, right? If it's negative and you subtract 1, it goes down. So -2 is what we're dealing with here. And so that -1 times x to the power -2 can be written as -1 over x squared. And that's our derivative, right? So we had our original function. There's the derivative of that function. Okay. So using the power rule. Second example, let's call this one g. Let's look at the square root of x. Now, again, helpful to remember how to represent things as power functions. A square root is the same as a 1/2 power. So x power 1/2. And so now we can apply our power rule on that at g prime of x. This is going to be take the power, bring it out and make it a constant multiple in the front, and then multiply it by a power of x where the power is 1 less. Okay, so we need to take our 1/2. We need to subtract 1 from that. What is 1/2 minus 1? It's -1/2. Okay, make sure to subtract carefully. Subtract 1. -1/2. So this can be written as 1/2 times 1 divided by x to the 1/2. Means the 2 and the x to the 1/2 are together in the denominator. You could write it like that, or reinterpret that x to the 1/2 as a square root. You get that 1 over 2 times the square root of x. So that's how we can use the power rule on rational functions, or some simple rational functions, on radical functions. This works for 1/3, for -3/5, any fractional power that you want. And then the last example I'll do is just to demonstrate, just to sort of like clarify, yeah, even if this is some sort of irrational power, I'll take everybody's favorite irrational number, pi, we can still do a derivative on this by doing the power rule. Pi minus 1. Whatever pi minus 1 happens to equal. Pi minus 1, if it's 3.14, I guess pi minus 1 would be like 2.14. Something about that. So yeah, okay, so that's the power rule and how to use it. We'll be using this one a lot, but this is only the tip of the iceberg. There's plenty of other differentiation rules